Hey guys, and welcome to P5. In P5, we are reminding ourselves all about factoring and all the special forms of factoring. So let me give you a quick rundown. So your basic form of factoring, the thing you want to check for first every time is your GCF, your greatest common factor. And then you start getting into factor by grouping, which usually happens if you have four terms or more, which if you're looking at the screen right now, number four is an example of factor by grouping, which we'll look at when we get there. All right. And then so those are your two basic forms of factoring. And then you have your special cases, which are your uh, difference of two squares. And then you have your ones that fit a pattern, which is your sum and difference of two cubes. So you only have a difference of two squares, but you have a sum and difference of two cubes. You also have um, the situation where you factor everything completely and your parentheses are the same. And so it's essentially that parentheses squared. All right, so that's what we're dealing with here. Okay, so that's a quick rundown. Let's take a look at some of these. All right, so number one, you should notice off the bat that you got 16 is a perfect squared and 25 is a perfect squared. And you're subtracting. So this is going to be that difference of two squares situation. So what's the square root of 16? 4. I'm going to go in both parentheses. X squared is going to break down to x and x. The square root of 25 is 5. So it's going to be 5 in both parentheses. And then you're going to have one of each sign, plus and minus. And that's all you do. That's the difference of two squares. On number two, this is not a difference of two squares. We have a middle term. Um, so I'm going to have to do one of two things here. I'm going to have to do factor using the AC method, which we'll do in a second. But, or if you look at the first term and the last term, and they're both perfect squares, all right, then give this a shot. So on number nine, or sorry, number two, you have 9, which is 3x and 3x. 16 is, square root of 16 is 4. Because my second sign is positive, so I got plus 16. That means both signs are the same as the first sign. So because it says plus 24x, it's going to be plus and plus, which means these are the same. This is repeated parentheses. Now, this was more of a guess because I noticed that I had a perfect square in the front and the back. So let me do a quick calculation to make sure that I'm on the right track with my middle term. If I do the inners, I get 12x. If I do the outers, I get 12x. And 12x and 12x is 24x. So this is going to work. And so this is going to say 3x plus 4 all squared. So you could leave it expanded like I originally wrote it, or you can run it like this. It's more important that you recognize that these are the same thing. 3x plus 4 all squared is the same thing as writing it out twice. And later on, we're going to see that, uh, or part of your homework is even that you're going to have uh, 3x plus 4 or something like 3x plus 4 all squared. And you're going to tell me, are you going to have a middle term or are you not going to have a middle term? That's where students get tripped up on, is because they square the first term. They see something like this, our final answer number two, and they square the first term, they square the second term, and they forget all about the middle term. And that's how they get it wrong. They're close. The close is not good enough here. All right. Number three, we have x to the fourth, x cubed, x squared. So I know all of them have at least an x squared that I can pull out. All right, 4, 12, and 44. I know that every one of these has at least a 4 that I can pull out. So I'm going to pull out a 4x squared, and that's going to leave me with x squared minus 3x plus 11. Okay, and and then that trinomial doesn't factor. So this is my answer. This is just a simple GCF problem. Okay. As I mentioned before, 4 is factored by grouping, which means I'm going to take my first two terms, group them together, my second two terms, group them together, and I'm going to pull out whatever. I'm going to take a GCF of both parentheses. So in the first parentheses, I have x squared that I can pull out. It's going to leave me with x minus 6. And because when it comes to factor by grouping, you're going to essentially factor GCF twice. Okay, and so because I've already done it once and I've got an x minus 6 in parentheses, I would really like the second parentheses to say x minus 6. And so that's going to be in the back of my head while I'm trying to figure out what to pull out on the next one. And I say that because sometimes it requires pulling out a negative number just to make all the signs and stuff work out. So just keep that in mind. So this is going to be plus 7, and it's going to leave me with x minus 6. Okay, now both terms now have an x minus 6. Let's pull that out. X minus 6, x squared plus 7. Okay, and there's that. That's factor by grouping. Now, on number 5, when it comes to basic factoring of a trinomial, you really want that first term to be a positive 1 have a positive 1 as a coefficient. If it doesn't, you might want to look for a GCF. In this case, on number 5, there is no GCF. 5 is not a perfect squared. 32 is not a perfect squared. So we're kind of stuck. We're going to have to factor this. But I don't recommend factoring it as it is. I recommend forcing that number in front to be 1. So here's what we're going to do. This is called the AC method. I'm going to take the 5 and I'm going to kick it to the back, multiplying when I get there. A squared minus 6a. 5 times negative 32 is going to be 160. I think that's right. Yep, 160. So I have a here. Okay, so I know that number's a little big, but we can handle it. And so now I'm going to factor this. Like going a squared goes here. It's going to break down to a and a. My second sign is negative, so I'm going to have a plus and a minus. And I need to figure out what times what is 30 is 160 and subtracts to give me 6 in the middle. Well, you'll just need to go to town working on um, what are my factors of 160. And so we're going to, so let's write them out. Obviously, we got 1 and 160, be 2 and 80, 4 and 40, 5 and 32, 8 and 20, and 16. And that's it. Well, because you're subtracting, which ones are 2 units apart? Well, it would be these. So which one goes where? My signs are different, so it matters where I put what. Okay, so uh, the middle term is negative. So the bigger of my two factors gets the negative sign. So it's going to be plus 10 minus 16. Okay, now when I started this problem by multiplying 5 to the back. So now I have to undo that. This is where if the wheels are gonna fall off, it's gonna happen here. But pay close attention. I'm gonna divide each of these numbers by 5. Okay, if it can reduce, that's awesome. So this one's gonna be a plus 2, right? But 16 over 5 doesn't reduce. Because if it did reduce and still didn't get rid of the denominator, you would treat it the same way. Uh, so like if this was 10 over 6 and it reduced to 5 over 3, well, it reduced, but I still have a denominator. So if I still have a denominator after I reduce, then I'm gonna take that denominator and I'm gonna kick it in front of the a. And so this is gonna be 5a minus 16. This is the factored form of number 5. Okay. On number 6, just because it has x to the fourth doesn't mean we're not dealing with a difference of two squares. A difference of two squares, you just have to think in terms of exponents, you just have to think, is it an even number, something that I can break in half? Okay, so this is going to be 9 um, x squared minus 16. Let's do plus first, and then 9x squared minus 16. Okay. Well, 9x squared plus 16, that's good. It's a plus. Both terms are perfect squares, but I'm adding, so I can't do anything with that. So I'm going to bring it down. X squared plus 16. But 9x squared minus 16, I'm still dealing with the difference of two squares here. So I'm going to have to factor again. So the square root of 9 is 3. So that goes here and here. X squared breaks down to x and x. Got plus, minus, and the square root of 16 is 4. 4 and 4. And so I had a difference of two squares 2 different times, and I had to factor. So you just have to factor multiple times. Now, starting with number 7, this is a sum or a difference of two cubes, right? And that follows a particular pattern. Okay, so you have a binomial, and then you have a trinomial. Okay, the pattern holds regardless if it's a sum or a difference. But I'm going to take the cube root of the first term. So in this case, it's just going to be z. The cube root of the second term, which is just going to be 7. And I'm going to keep the original sign. So to get my trinomial, everything in my trinomial is based off of what is in my binomial. So it's important that you are able to get the cube roots correctly. Okay, well, you square your first term. So This is my first term. This is my second term. Square my first term. It's going to be z squared. You take the opposite sign of the original. So now it's going to be plus. I multiply my two terms together. So this is going to be z or 7z. And then I'm going to square my second term. And because I square it, that second sign will always be positive. And then 7 squared is 49. And this is your answer. If the difference of two cubes, that's what it looks like. If this was the sum of two cubes, the first sign in the original would be different, and the first sign in the trinomial would be different. But everything else, the pattern still holds. Okay. And if you rewind this and think about how I explained the binomial versus the trinomial, that pattern holds regardless of whether you're adding two cubes or subtracting two cubes. Okay, so this is close to something that we can work with. But let me take a 5 out. That's going to give me x to the fourth minus 81. Now, should be a little bit more obvious to you. If this is difference of two squares, this is going to be x squared plus 81. Sorry, plus 9. X squared minus 9. X squared plus 9 is going to come down. And then I'm going to have to factor this again because the x squared minus 9 is also a difference of two squares. So x plus 3, x minus 3. Okay. And that's that. You just keep factoring until you can't factor anymore. Okay. On number 9, you can only factor something like this that has two terms in it if they're subtracted. And you have two perfect squares. They are perfect squares, but they're not subtracted. So I can't factor this, which means we call it prime. We call it prime. If you can't factor, we call it prime. Okay. On number 10, they count your greatest common factor. They both have at least a y cubed. So I'm going to say y to the fourth. That's 81 on the inside. And now that is difference two squares. So the y cubed is going to hang out. This is going to be y squared plus 9, y squared minus 9. Right? As you've seen from the last few problems, the plus 9 or the sum of two squares just comes down, but the difference of two squares has to be factored again. So this is going to be y plus 3, y minus 3. Keep factoring until you can't factor any further. Now, how am I supposed to factor um, with fractional exponents? Well, that's a good question, but it's not as hard as you think it might be. Okay, they both have at least 1/7. So if I take out 1/7, um, this is going to be x 1/7. And then if I say 5/7 minus 1/7, that's 4/7. So that's going to be x to the 4/7. And then when your GCF is one of your terms, you have to replace it with 1 because you should be able to multiply back to get what you originally started with. Now, this is a little more advanced, but I'm still going to tell you, um, even though this is 4/7, this is still a perfect squared. Because again, remember, you're trying to break it in half. And 4 is in your numerator. I don't really care what the denominator is, but the 4 is in the numerator, and I can break 4 in half. So this is the same thing. 1/7 is going to hang outside, but this is the same thing as x to the 2/7 plus 1, x to the 2/7 minus 1. So technically for this problem, they stopped here, but you could um, go this far with it, depending on how they ask you to do it. So just so you know. All right, number 12. This was tricky. It's very similar to number 11, but it's tricky only because the bigger fraction is in the back. Because of the bigger fractions in the back, I'm not just going to take out an x plus 6 to the 1/3. I'm going to take out a negative when I do it. So it's going to be negative x plus 6 to 1/3 times, and that's going to be, let me come at this a different way. I'm just going to take out the x plus 6 to the 1/3. And that's going to leave me, again, when your GCF is one of your terms, you have to replace it with 1. So this is minus. And when I take 1/3 from 4/3, it's going to be 3/3. So this is going to be minus x plus 6 without an exponent at all. Okay, well, watch this. I have x plus 6, 1/3. Um, I'm going to distribute this negative because this is what you do. When you subtract your parentheses, you distribute that negative through the parentheses. That's going to be 1 minus x minus 6. Okay. This first term's just going to hang out with this for right now. All right, that's going to be negative x. 1 minus 6 is negative 5. Okay. Now, I don't really like the whole negative x minus 5 thing. I really want my x to be positive. So I'm going to pull out a negative. I'm going to pull it all the way out front. And that's going to allow me to change my signs um, inside. So it's going to be a positive x and a positive 5. Sometimes picking out a negative makes all the difference. And all it does is a sign change. So you can pull out a negative, even if it is not helpful, you can pull out a negative. But um, in this situation, um, this is where they stopped in your homework. But I would not have pulled out a negative unless it was actually beneficial. In this case, um, it's more of a preference. But as you'll see as we go forward, as we talk about rational functions and there's things that I can cross out, it might be helpful to go ahead and take out that negative so that things match up and I can cross out. But that's a different lesson for a different day. Okay, now on 13, our last problem here, you look at each term. What do they have in common? Right? You have an x minus 4 in every term, which means that's my GCF. So I'm gonna pull it out, and that's gonna leave me with 8x squared minus 6x minus 5. Okay, now I'm gonna have to do the AC method. So I'm gonna throw this 8 to the back. The x minus 4 is just gonna hang out while I factor this. So this is gonna be x squared minus 6x minus 40 x and x. My second sign is negative. This is gonna be plus, minus. And then your factors of 40 are 1 and 40, 2 and 20, 4 and 10, 5 and 8. That's it. So what times what is 40 and subtracts to give you 6? Well, 4 and 10. So, um, and because 10 is the bigger term, it's going to get the minus sign. So plus 4 minus 6. Okay, well, I multiplied by 8, so I have to divide by 8. In both of these, I will be able to reduce, but my reduction does not get rid of um, my fractions. It's going to be 5 over 4. Okay, so if you don't see, if your reduction doesn't take care of your fractions, you take whatever the denominator is, and you kick it in front of the x. So one last time, x minus 4 comes down. This is going to be 2x plus 1 and 4x minus 5. And this, my friends, is the complete factor form of 13. Okay. All right, if you have uh, any questions about any of these problems, please schedule a meeting with me and reach out. Um, if you have any if you need help with your calculator or anything, let me know, and I will see you in the next video.